Hello. In the last session, we have tried to understand what exactly is kinematics of machines, or what is the study we are going to do, wherein we have started with what is a machine, right? And we have reached till the science of mechanics that we have seen. Just briefly I am going through science of mechanics, and this study is divided into statics and dynamics, where this dynamics is again, the study of dynamics is again subdivided into two areas, which one is kinematics and the other is kinetics. So in kinematics, what we are doing, we are studying purely only the motion, that means displacement, rate of change of displacement, which is velocity, and acceleration, which is rate of change of velocity. Whereas in kinematics, we are as well involving the forces which are causing these motions. Right? So entirely, if we see now here, to again relate these things, in this session we are going to study certain specific definitions, terminologies and assumptions which we are considering in this study. Now we are restricting our study, or we will be restricting our study in kinematics, but before that we need to understand the terms which I have used as machines and mechanisms, right? Now for that we will take a simple example. What can be a best example is, let us say I want to design one car, right? Now what is the objective of this car or a vehicle? That it must carry certain people, certain number of people, or maybe certain load for that matter. And how its motion should be? So definitely the motion of this vehicle must be definitely linear, because it is going to move on the road. And to achieve this motion, how the wheels are moving, you will see that the wheels are having rotational motion, right? So when the wheels rotate, the vehicle will have linear motion. Try to understand. So these are two different types of motion which are involved. So that means there is a need of understanding motion, right? So for this, we will go through or try to understand a simple example. Now to run this car or to move this car, I need a powerhouse, right? Now this powerhouse is called as an engine. So more or less you have an idea how an engine works. So there is one component which is called as a cylinder. So what we do, we burn fuel inside the cylinder. Now if I burn fuel on a plate, this entire energy is going to get wasted, or it will dissipate in all the directions. Now if I give it a specific direction, that entire energy will be directed in a specific direction. So what I do is, I take a cylinder, I place a piston inside it. This component is called, so this is the cylinder and this is the piston. So then what we do, we bring in charge. What is a charge? It is air fuel mixture, and I burn it. So I supply a very high voltage, high temperature, high pressure condition I create, and I burn that fuel, and that fuel is going to explode. So when it explodes, it is going to push this piston outwards. So as we have specified the direction, the piston will have only one direction to move out, right? So this piston will start moving in this direction. Now what I do is, I connect another member to it. Say this is the other member which I connect to piston. Now when I make this connection, I ensure that this is kind of a movable joint. Anyway, so when this member is moved, of course, see, now the cylinder is component 1, the piston is component 2, and this is the component 3. So along with the piston, the component 3 is also going to move. Then what I do, I join another component, a component number 4 to it. So if I look at this assembly now, this entire piston is going to move out. So it is going to push this component number 3. The component number 4 is connected to 3. So 4 is also going to get pushed. But now what I do, say if one member is moving like this and I restrict its linear motion from one end. So of course this is going to turn, right? So I place it on, or I fix it on some member, right? So what is happening in this case? So when this is pushed, 4 is pushed, but I am restricting the motion of one end of this component number 4. So instead of having a linear motion, this will start rotating, right? So when this starts rotating, so I get this member, which I call it as a shaft. You must have heard that term. So this shaft starts rotating. Now if kind of a pictorial view, if you want to see, I have placed the connecting rod somewhere here. So this connecting rod is fixed to this one. So when this rotates, the shaft is rotating, and I now place a wheel on this shaft. So ultimately this wheel starts rotating. So in this entire discussion, if you see, we have focused only on how to rotate the wheel, right? We were least bothered about how many people my car is going to carry. So we were not concerned about what are the forces required, what is the energy required, or for that matter power required or bhp required for my vehicle. My entire focus was only primarily to rotate the wheel, so that until and unless the wheel rotates, the vehicle is not going to have the motion, right? So that means in this entire arrangement what we try to create, we were focused on motion. That means the input was the piston motion and the output was the rotational motion of the wheel, right? So our focus was entirely on motion, for which we have created this arrangement, and this arrangement or this study, this is called as a mechanism, wherein we are focused only on the motion. The moment we involve how many people it is going to carry, what is the exact required work done, that gets into. So entirely car, if I am talking about, which can carry 4, 5, 6, 7 people or a load of certain value, then that study will be, or that will be called as a machine. So I hope you have got an idea what exactly we are talking about, a mechanism and a machine. So now we are in a position to define what is a machine and what is a mechanism. Now in entire this thing, we have been talking about these components. Now of course, even if I want to transfer motion from one end to, or one point to some other point or output point, definitely whatever members which we have considered, they need to be rigid. That means whatever, see anyway, if I want to execute motion on a body, definitely I need some force. Now if this, let us say I am applying some force, and instead of this to be a very solid material, if this is made up of let us say rubber, so if I am apply force, it is going to bend, right? So if it bends, then though this point or this end moves, this end will not have any kind of motion until and unless this entire body is a rigid body. So if this body, so that means what is a rigid body? We are saying if there is application of force, external force, so this, say there is a force applied, so it takes a position 2. So if I call this as these 2 points on the body A and B, after application of force it is A1 and B1. But what I see, the distance between A1 AB and A1 B1, this is not going to change. If this is not going to change, I'll call this body to be as a rigid body. Right. So this is one assumption. In case of study of mechanisms, we are considering all these bodies to be as rigid bodies. Now, calling these to be rigid bodies will be a very hypothetical term, because we cannot say any body is a rigid body, right? So we are calling this to be as resistant bodies. So these are resistant bodies. That means for the given force conditions, these bodies are going to perform as rigid bodies, so that the motion is transferred properly. So now we can get into or we try to define machine and mechanism. So what is a machine then? I can simply say that machine is combination of resistant bodies. Now they have to be arranged specifically, right? So this is a combination of resistant bodies so arranged that by their means the mechanical forces of nature are compelled to do work. Now, when I say work, this work has to be useful work, right? Until and unless it is useful to me, there is no point in designing a machine. So it has to be some useful work accompanied by certain determinate motion. If you remember, our focus was to turn the wheel. So that was a specific motion I needed to have those wheels. Until and unless the wheels rotate, the vehicle is not. So the output, I want motion as well as I need work. That means work done to be there. So when it is a machine, so I can say machine is combination of resistant bodies. This is again one of the key words. The bodies or the members which are connecting each other, these are called as the resistant bodies. So arranged. See, we had a specific arrangement. The cylinder, then inside which I had a piston, then I connected the third link, then the fourth link as the crank. So they are so arranged that by their means, what we are doing, we are utilizing the forces of we are burning the fuel, so we are using the energy of the fuel, and we are compelling that to do work for me. It needs to move, so accompanied by certain determinate motion. Now, in this regard, then again we can define what is a mechanism. So what is a mechanism? So we can again say mechanism is assemblage of, again definitely, resistant bodies connected by movable joints. So of course the members connected to each other, they must be movable joints to form a closed kinematic. So we will talk about this, what is kinematic chain and all, in our latter part of study with one link fixed and having a purpose to transform motion. So if you see mechanism, in mechanism we are talking about only the motion part. Our entire focus is on the input, what is the input motion and what is the output motion. So I am transforming motion. As we have seen in case of the piston cylinder arrangement, the input motion is linear and the output motion is rotational. And in case of machines, the input is some force and the output is work done. So that's all for this session.